Hello students, welcome to Vyas Certification Quota. Yes, it is time to continue further with the chapter Permutations and Combinations. The first exercise was pretty simple and it was a pretty small exercise but very important. Very crucial exercise. It was based on the fundamental theorem of counting. The next exercise is based on some calculations related to factorial. The first time you are introduced to factorial and you are supposed to do some calculations based on that, solve some equations based on that. This is what the second exercise is based on. Once again, a relatively simple, small exercise, and if you know the basic concepts of factorial, you will be able to solve all the questions of this exercise very well. Let's discuss the questions from Permutations Combinations exercise 7.2 over here. First question says evaluate 8 factorial. Oh, we are supposed to find that 8 factorial. Yes, let's find that 8 factorial. You should remember a few factorials, right? A few factorials, yes. Let's say 1 factorial is pretty simple. 1, 2 factorial is 2, 3 factorial is actually 3 times 2, which is 6, right? You can understand or you can find 3 factorial in two ways. This is 3 times 2 times 1, which is 6, or you could directly do 3 times 2 factorial, which is 3 times this 2, which is 6, okay? Further, 4 factorial can be similarly found in terms of 4 times 3 factorial, which is 24. 5 factorial, instead of multiplying all numbers from 1 to 5, let's multiply 5 times this 24, which is 4 factorial. What is that giving me? This is 120. 6 factorial will be equal to 6 times 5 factorial. What is that? 6 factorial is 720. 7 factorial. Now up till 6 factorial, if you memorize, at least memorize up to 5 factorial, this is important. Even 6 factorial is pretty simple, right? 7 factorial onwards, if you memorize it is good, but if you don't, then also it's okay. This is 7 times 720. 6 factorial. What's that? This is 0, 7 times 2 is 14, 4 and 5040 is what I get. 7 factorial is 5040. Then you have 8 factorial. 8 factorial will be 8 times 7 factorial, and this is what is required. This is 8 times 5040, and what's the value? This is 0, 8, 4, 32, 2 and 3 carry 8 times 5 is 40, 40320 is the value of 8 factorial, and that's my answer for the first part. What about the second part? Second part is pretty simple. 4 factorial minus 3 factorial. Now, if you remember 4 factorial, it's very simple. This is 24 minus 6, which is 18. Or alternatively, if you are given 2 consecutive terms or similar, close enough terms in terms of factorial, what you can do is 4 factorial minus 3 factorial can be written in terms of 4 times 3 factorial minus 3 factorial. Oh, why are we elongating this whole thing? Just to give you a glimpse that it is very simple, right? This is 6. And this is 3, which is 18, right? This is an alternate approach, which is also okay. This is pretty simple. This is what you can follow. We could calculate 8 factorial directly as well in the first part. Yes, we could have calculated that. But then you should memorize these values, and therefore I have mentioned them in front of you. If you memorize this as well, then it's very good, right? Up till 6 factorial, 720 is the value, and that is something which you should memorize, right? With this, that's the end of this complete question. And let's move on to the next one after this. The question says, is 3 factorial plus 4 factorial equal 7 factorial? Does not look like. 7 factorial is a huge number. We just saw 7 factorial is actually 720 times 7. Now I'll continue from there, right? 6 factorial is 720, I remember that, and 7 factorial is this is 5040. Oh, but 4 factorial is 24 and 3 factorial is 6, so adding them together will give me 30. But 30 is not equal to 5040, so the answer is no. No, they are not equal. 3 factorial plus 4 factorial is not equal to 7 factorial. Factorial does not work in this manner, right? The result related to factorial that we have is n factorial is equal to n times n minus 1 times n minus 2, and this can be written as n times n minus 1 factorial. At max you can write this. This is one of the results which is based on factorial. You don't have any of these results that x factorial plus y factorial will be equal to x plus y factorial. That's not true, and therefore no over here. Let's discuss the next one. This compute 8 factorial upon 6 factorial times 2 factorial. How do we do that? Once again, a simple approach. 8 factorial over 6 factorial 2 factorial. This can be simplified as 8 times 7 times 6 factorial, right? I can break it into this manner. We have a 6 factorial in the bottom. Yes, we'll use that 6 factorial. This is 2 times 1. 2 factorial is 2 times 1. This 6 factorial goes with this. 2 goes with 8. And what you're left with is 28. That's your answer for this question, right? Later on, we'll also see that 8 factorial, 6 factorial, 2 factorial is actually equal to 8C2 or it is equal to 8C6. Oh, it is equal to both of these things. What I'm saying is that expression over there can be written in this manner. That's a shorter version of writing that whole thing, and finding the value would be this process only, right? We'll find the value using this idea only, right? But this is not something I want to deal with right now. It will be dealt with after a few exercises, right? So that's question number 3. Let's move on to the next one. Question number 4. Okay, this is an equation based on factorials, right? So let's try to solve this equation. This is 1 upon 6 factorial plus 1 upon 7 factorial is equal to x over 8 factorial. For finding x, we can multiply throughout by 8 factorial, and what do we get? X will be equal to 8 factorial over 6 factorial plus 8 factorial over 7 factorial. This is 8 times 7 times 6 factorial over 6 factorial, they will get cancelled, plus 8 times 7 factorial over 7 factorial, this will get cancelled. So this is 8 times 7, 8 times 1 will be 8 times 7 plus 1, which is 8 times 8, 64. That's my answer for this question, right? 64 is the final answer. The value of x is 64, as you can see behind me. Moving on to the next one, this question. Evaluate n factorial upon n minus r factorial when n is equal to this for the first part. So n factorial upon n minus r factorial will become equal to 6 factorial over 6 minus 2 factorial. This becomes 6 factorial over 4 factorial. Is that okay? And this can further be written as 6 times 5 times 4 factorial upon 4 factorial. This goes. So this is equal to 30. That's my answer for the first part. Let's talk about the second part then. N factorial over n minus r factorial, where n is 9. So this becomes 9 factorial over 9 minus r is 5. This factorial. This is 9, 8, sorry, this is first of all 9 factorial over 4 factorial, right? Let's observe that. And we can write 9, 8, 7, 6, 5 times 4 factorial. This is the numerator, right? 9 factorial can be written in this manner. While we're writing in this manner, so that we can cancel these 4 factorials, right? And this is what we get. How do we find the values? The values, let's multiply them together. And what is this? 9 times 8 times 7. This is actually 8 cube minus 8, which is 5 and 2 minus 8, which is 504. 504 times 30 is what is required over here. And this is 4 times 3. There's a 0. Okay. 4 times 3 is 12. Okay. 5 times 3 is 15. 1, 5, 1, 2, 0. That's the answer for this one over here. N equals to 5 and r is equal, n equal to 9 and r is equal to 5. That's the solution of this question over here. Yes? Is that all? Yes. And yes, with this we come to the conclusion of this exercise 7.2 from the chapter Permutations and Combinations. In the next session, we'll be talking about the next exercise. Till then, all the best.